Hello everyone, my name is Jackson Valentine and today I'll be presenting on PostgreSQL, one of the most widely used and secure open source database management systems. I'll be covering how PostgreSQL functions, how it's configured on Linux, and how to harden it against potential vulnerabilities. PostgreSQL plays a massive role in enterprise environments, and understanding how to deploy and secure it properly is critical. By the end of this presentation, you'll have a strong grasp on how PostgreSQL supports data management and cybersecurity's best practices. We'll start with an overview of how PostgreSQL and what makes it so important for modern computing. Excuse me. Then I'll explain how to install and configure it on a Linux system. Next, I'll review several common security risks that administrators face. From there, we'll explore specific hardening recommendations to secure the database. And I'll also go over some real-world applications where PostgreSQL is used successfully in enterprise environments, followed by key takeaways and references. Alright, PostgreSQL is an advanced open source relational database system. It uses SQL language to manage structured data efficiently, but it's also capable of handling semi-structured formats like JSON. PostgreSQL is known for its robustness, repeatability, and ability to handle complex queries, large datasets, and concurrent users. It listens on TCP port 5432 by default and uses ACID compliant transactions, ensuring reliability and data consistency. The system is widely used across industries, from financial institutions to tech startups, due to its strong focus on security, scalability, and extensibility. So going over the overview again, it's open source relational database. Its default port is 5432, supports SQL, JSON, and advanced indexing, and it's used for secure data management. Alright, to configure PostgreSQL on Linux, first install it using sudo apt install PostgreSQL PostgreSQL-contrib. Once installed, you'll find configuration files in /etc/PostgreSQL, then its version, and then /main, with another slash. The two most important files are PostgreSQL.config and pg_hba.config. The first file manages general settings such as which IPs the database listens on and which port it uses. By default, port 5432. The pghba.config file controls authentication methods. Secure configurations use MD5 or scram.sha.256 authentication instead of weaker methods. After updating configurations, restart the PostgreSQL service using sudo systemctl, restart PostgreSQL SQL, and verify it's running properly using sudo systemctl status PostgreSQL. So again, the overview here is install using apt package manner, edit the files, enable listening on port 5432, and then restart and verify the service. Like any database, PostgreSQL can be vulnerable if not configured securely. Weak authentication methods or plaintext credentials can allow unauthorized access if SSL and TLS are not enforced. Attackers could intercept communications between the client and the server. Another common issue is privilege escalation, where poorly defined roles give users more access than necessary. Finally, if PostgreSQL listens on all interfaces without firewall restrictions, anyone scanning the network can detect and attempt to exploit it. These issues highlight why hardening PostgreSQL is a critical part of server management. So here are the security risks again: weak authentication or plaintext credentials, unencrypted client-server communication, privilege escalation due to misconfigured roles, and open network exposure on port 5432. The first hardening step is enabling SSL or TLS encryption. By default, PostgreSQL may allow unencrypted connections, meaning all data, including passwords, is set in plain text. In PostgreSQL.config, set SSL equals on and provide certificate and key files, ideally signed by a trusted certificate authority. This ensures all connections are encrypted, protecting sensitive data from eavesdropping or tampering. In enterprise environments, enforcing TLS 1.2 or higher is standard, while older protocols should be disabled to reduce vulnerabilities. So for the hardening recommendation number 1, enable SSL in PostgreSQL.config, use certificates from trusted authorities, and encrypt all client-server communication. Alright, so on to our next hardening recommendation. Implement role-based access control. PostgreSQL allows to create roles with significant privileges. For example, one role for reading data and another for writing or managing tables. The key is to follow the principle of least privilege, giving each user or service account only the permissions necessary to perform their tasks. Avoid using default Postgres super user account for daily operations, as it has unrestricted access. Instead, create limited roles for regular activity and reserve the super user for administrative maintenance. Alright, so for rule number 2, role-based access control, create user roles with least privilege, avoid using the Postgres super user, and separate roles for administration and applications. Alright, on to the third hardening recommendation, the final one. Alright, this step focuses on network exposure. The Postgre config limit the listen addresses setting to only trusted systems such as localhost or internal IPs. Use a firewall such as UFW or IP tables to restrict access to port 5432 from unauthorized hosts. Additionally, ensure that configuration files like PostgreSQL.config and pg_hba.config are owned by a Postgres user, not writable by others. This prevents tampering and ensures that only authorized administrators can modify database settings. So for the third hardening recommendation, limit listen_addresses to trusted IPs, restrict port access via firewall, and secure configuration files. Alright, so some real-world applications. PostgreSQL's stability and security make it ideal for real-world enterprise environments. Apple and Cisco rely on it for back-end data management, while Spotify uses it to handle massive amounts of user data in real time. Healthcare organizations use PostgreSQL to securely manage patient records, meeting compliance requirements like HIPAA. Government agencies also prefer PostgreSQL for its open source transparency and security certifications. These examples show the same configurations we use in class directly reflect how professionals secure PostgreSQL in production environments. So the real-world applications are used by Apple, Cisco, and Spotify. It's common in healthcare and finance, and it's been trusted by the government and enterprise data. In conclusion, PostgreSQL is a robust database that can be secured with proper configuration and hardening. Its default setup is functional but not always secure. By enforcing encryption, applying role-based access control, and limiting network access, we significantly improve security. These steps not only protect sensitive information, but also build professional habits that align with real-world cybersecurity standards. So our key takeaways are PostgreSQL listens on port 5432, encryption protects data in transit, role-based access reduces risk, and restricting network exposures strengthens security. Alright, so for the references, there are the main sources for configuration and hardening guidance. Canonical's Ubuntu documentation provides detailed Linux setup instructions, while PostgreSQL's official documentations offers technical configuration details. OWASP, Mozilla, and NIST all contribute to secure database and encryption. best practices applied directly to PostgreSQL. Alright, thank you for watching my video.